So we can create a new project, ba? So we'll click on new project. Similarly, you just select a template, and then you give the project code. Still, you can name it still design. Okay, to do a steel design, similarly just like the concrete, you pick a template bar, then you give it a name, and then you click on OK. When it comes to steel design, there are two things you require from the architect. Most especially, the major thing you request for is the cross section, so that you will see how the roof pattern yake based on industry architect yasa. So the roof cross section, it can come in curve shape, it can come however it comes. Shima one, just like the concrete, you can import a steel truss cross section. You can import it, and you can as well model it from here. The software has different steel cross section pattern that you can pick from and you can modify. So let me check if I can find. While it's still loading, let's quickly do a simple model now. Steel. So most time steel spans they are usually large in most cases. So I'm just going to do a very simple demonstration, since at the moment I don't have any. I have, but it's loading at the moment. So let me wait for it while it loads. But while it's still loading, I can just do a very simple demonstration. I believe we understand how this is. So if I click on OK, I can click anywhere in my window. Now similarly, just like the concrete, when you come to your model, it has steel members. You click on this drop down menu, you can see a steel column, a steel beam, a truss, a pull line, a guards, a brace, cladding, steel dome, frame. You are going to see how I'm going to demonstrate some of this as we proceed. Now, the first structural member I'm going to pick is my steel column. Once I click on my column, this menu that pops up here, I can click on this section manager, and it will take me to different type of steel cross section. So this is what we call an I section. So you can see this is BS. It's still loading. So you can see different shape. This one is hollow, this one is I section. You can see different section T, and then the circular one is here. It has a tool for you to rotate. If you want to rotate this, you can see from the preview So this is actually the cross section no one and still member them. So just the way it is represented here is basically what I have here. So this information, if you change any of this information here, you are going to see it taking effect from here. But I will encourage you or advise not to tamper, because this is based on BS, British standard, so all these cross sections are in standards. So on any of the cross section yana the list that it can bring out for you here. Then saboda she still yana the kaman just like a chart or like a table you can play along with. So you can select your section here. If you are viewing my screen from here, you can select a section that suits your design. But the good thing about steel design shine, there's what we call utilization ratio, and there's what we call slenderness ratio. So this utilization ratio and the slenderness ratio will help to tell us if the steel cross section could pass. It will help to tell us whether the cross section is too large or that cross section is too slim, which is the slenderness ratio. The utilization ratio help to tell us even when it passes, it will guide us so that we will know that cross section is too large, so it's definitely not going to be economical. That's about that. It's very expensive. All these steel members are expensive. To buy them in the market, they are expensive. So let's say I'm going with this cross section 305 305.97. If I click on select and I click on OK, just like I said, you must have an intersection between two grids before you can insert any structural member. So all I need to do is just to insert my steel members. The good thing about steel shine, it can go a very large span by common concrete bar. So just like you do for your concrete, you can as well add stories. It's important to add story because you are going to have this steel column resting on a reinforced concrete column. Then we will have what we call the base plate. So I will do the Ctrl Z to undo all the structural members that I'm inserting, and then I will come to my stories here and I will right click and I will click on insert story. So I will insert my number of story. I will type 2 and I will click on OK and I will click yes. Now when I come to these stories by the left hand corner of my screen, I will right click and I will click on edit story. So if I click on this edit story, I can specify the height now concrete column that I want. So let's say that concrete I want it to be 600. So it's going to be 600, and then this one, let's say, is going 6 meters high. So here now, this can be switched to a steel member, and then I can leave this one as a concrete member. Then I can also specify the depth of my foundation, but let's say I want to maintain the 1200. And then if this is what I have, very important, I can switch this to a 3D physical model, and then I can have my 3D and also have my 2D here. When I come to my view tab here, I will click on tile vertical. Then I can have a plan view and 3D showing on my screen at the same time. So whatever I do here in real time, you see it's taking effect on my left side, right hand side of my screen. Now if I come to my modeling here, I will insert the concrete. Now let's say I want to use a concrete column of 400 by 400 because it's going to be carrying a steel member. So and then the height is 600, which I have already specified from the stories. So the moment NASA, you see a very short This doesn't look like 600. This doesn't look like 600 anyway. Let me go back and check what is there. Edit story 1. It's 600. It's 600. It's correct. It's correct. Oh, I'm in story 2. That is why. Good. It's a good thing we are making this mistake, man. That's why I said we always pay attention to that story. It's very, very important. So you can go and finish your entire model in a different story. For me to switch to story 1, I'll first of all click anywhere in this window, and then I will double click on story 1. Now you can see it has changed. Then I will come to my concrete column here. I'll specify the thickness, the cross section of that column to be 400 by 400, for example. And then I will insert those columns. Let's say I just want to have it just by these 4 points. Is okay. Alright, then the next thing I will do is to insert my steel column. To insert my steel column, I will click anywhere in the window and I will double click on story 2. It has switched to my story 2, and I will come to this drop down menu and I will pick the steel column, and then I can change the cross section. Now one non-column. This one comes with years of experience. You'll be able to tell this is the steel cross section that will most likely probably serve. But even after picking it, the software will tell you whether that cross section that you have picked, whether it has failed or it has passed. That is designed for you.
What of the base plate first?
Base plate by number, sir. The base plate is not here. The base plate is, we are going to insert the base plate in Protasteel.
You have the Protasteel?
Yes, there's Protasteel. Everybody has Protasteel. Protasteel is a 3-in-1 software. The moment you install Protastructure, the Protasteel comes with it. This is Protasteel. So I will insert those steel columns where I want them to be. So if you look at the 3D, you will see the steel columns are resting on the concrete columns. So the next thing I will do is to come to this drop down again and select a truss. For example, if it is a truss I want. So if it is a truss, these columns are too small here. I'm supposed to have, sorry, I'm in a different story. I will switch to story 1. Make sure I have it here. So steel column, sorry, story 2.
What's it? That's it.
Okay. Comes in. Okay. What I will do now is to click on truss. For example, if it is a truss, we have portal frames. So if it's a steel truss, for example, I will click on the first point and I'll click on the second point, and a menu is actually going to come up. So let's wait for it. It's coming up. Now this is it. Now irrespective of how most of the architectural cross section will most likely fall within any of this pattern. So if I choose the curve one, you can see we have different pattern of the curve. If I choose this one, we have different pattern of this particular truss. If I pick this, we have different pattern of this truss. If I pick this, different pattern. So they've done a very great job in giving us different patterns. You can as well also import a steel cross section that is from the architectural drawing. That means directly the way the architect gives to you, you can import it, but there is some little editing you need to do on the drawing before you can import it from AutoCAD. So I'm just going to pick any of this cross section just to demonstrate. But if you look at this right side of my screen, it's like you are having like a form to fill. Now it allows you to pick, it allows you to modify this particular truss to however you want it. Most times, just like I said, it comes from the cross section that the architect is giving you. So if the architect is giving you the cross section to look like this, you can see you have a vertical chord, you have a diagonal chord, you have a top chord, then you have a bottom chord. If the architect gives it to you in a way that you don't even have a vertical chord, it's possible the cross section, the architect likes to give the engineer plenty problem. So it will come however it comes, so you can play around with it. So if you check the number of span here, it says 6. You can increase the number of span, so that means your vertical chords are going to increase. So if you count this now, we have 1 2 3 4 5 6. That is what it means. So you will do your editing here to suit the architectural drawing. If you look at this apex height, it says is 2,500. What will happen if I increase this to 3 meters and I press enter? You will see that this preview has increased in height. So that's basically how it is. You can also zoom in and zoom out of this particular preview. So if you see, there is no way, it's very, very interactive. If you see here, it is written HA. If you look at here too, it's also HA. So if you look at this HL, all you need to do is to check here, you see your HL. So similarly for all of them. You can also have what we call like a cantilever, where this one will come out common fascia. You can have it. So if you check here, you can see left cantilever, you can see right cantilever. So if I want to have a cantilever, for example, of 600, I can have a cantilever. If you look at the preview drawing, you will see that has been reflected. So however the architectural drawing comes, you can be able to manipulate it from here. So let's assume this is 100% how the architect has actually given us. All I need to do is to click on OK, and you can see that has been inserted. Similarly, I can just drop, I can come and drop, I will come and also drop. So let's say we are designing like a warehouse. Now what I'm going to do, I will add a gut to this, and then we can have our pull line, and we can also have our bracing. Now to add a pull line to this, if I also come back to this drop down menu which says steel members, you can see we have pull line, we have gut. So to click or to insert a gut, all I need to do is to click on it. I will click on the first column, click on the second one, and it is actually going to give us a menu like this. This menu too is like a form which you need to fill to suit whatever you want to do.
Please come again to the menu.
I should go back. Okay. If you have this and you want to insert a gut, all I need to do is to come to my steel members. I will click on this. It brings a drop down menu like this. I will select a gut. If I select it, I will click on the first member, click on the second member that I want this guard to span to, and this is a preview of how it's going to look like. You can see it comes with a sag rod. These are sag rods. I can turn off this sag rod, and I can also leave the sag rod if I want. So if you come to this sag rod, you can see auto. I can turn it off. You can see there is no sag rod anymore. So however I want it, if I want it with the sag rod, I can bring it back, and I can click on OK. And the span or the spacing in between this and this and this can also be edited, so however you want it to look like. And I'll click on OK. So this is literally just the modeling. So similarly you do for this, and click this and it comes up. So I can brace these columns and just insert a brace. But if you look at this as well, you can see that this guard is actually inside. I can bring it outside and for it to be here. So all I need to do is just to double click on it. Bottom, fill form from top. I will click on this. A drop down like this comes. I can click on under section. If I select the under section, I will click on OK. You can see it has come outside. So similarly I can do for this as well. I can decide to bring this one in however I want it to look like. But let's assume this is how we want this to look like, and I'm going to insert a brace. So if I click on brace, let's say I want to brace this column and this column, brace this column and this column. So I will click on the first member, click on the second member. A menu like this is going to pop up. So similarly for all the steel members, Hacker, it will keep bringing up this menu for us. All we need to do is just to take our time and edit it. So if I click on OK, you can see that has been braced. I can also brace these two columns and click OK. I can as well rotate this and brace these two columns and click OK. I can brace these two columns and click OK. Then what I will do now is to insert a poline for this. To insert my poline, I will click on the drop down as well and click on poline, and I can click on the first truss member, click on the second truss member, and I'll click on OK. But you can see there are so many informations here. Even the poline, you can change the cross section of your poline. You can change it. But let's say we want to maintain that cross section. I will just need to click on OK, and my poline has been inserted. I don't know if this is looking like a normal warehouse to us. So this is basically how to come about this. I can also brace this truss if I want. I can add a brace to the truss. So if I click on this, I can brace these two together. I can also brace these two together, and this is what I'm going to have. So I hope I'm not missing out any structural member. Okay, which one, sir? Cladding, have it?
The gusset plate.
Okay, gusset plate.
There's no way you can connect a concrete column with a steel column without the gusset plate.
Yes.
And
that's a base plate, sir. Which will not do it here. It's not going to be here. It's in Protasteel.
Okay.
Yes. It's in Protasteel. So all the connections can be done here. Your gusset plate, your base plate, your column to to truss connection, and think of any connection, man, can be done here. Even the sag rod connection can be done here. All the connections are not done in Protasteel structure, they are done in Protasteel. So I think this model is complete. Then all I need to do is to just design it. All I need to do is to run my analysis. So if I come to my analysis, come to building analysis. So similarly, just like we did for concrete schema, you can come to your edit material here. We have steel. We have this steel. You can maintain or use whatever steel grade you want to use. Even the steel, it comes in different grade as well. So however or whatever steel grade you want to actually use, you can select from there, and then you click on OK. And then just like we did, you can go to your settings center. This is just a repetition of how we actually, like a walkthrough of what we were doing in the concrete aspect too as well. So you can do your loading generator, load cases, and then you click on OK. But before then, this one you can here we need to check on create different combination for steel member design. So that has been selected, and I'm going to click on OK. Then I will analyze this model, but before then I can as well do a building model check. Good. So our model is 100% okay. There is no error. Everything is 0. So you can click on the log. All the possible errors we are supposed to have are all 0. So that means our model is perfect. So the next thing I'm going to do is to click on building analysis. When I click on my building analysis, it's going to load, and I will click on steel column, and I will click on concrete column, and I will click on steel member design check. So but don't forget, for the concrete column you need to specify the reinforcement that should be done. We've done that over and over again together, so it's just the same repetitive steps. All you need to do is just to put all of that in order, and this is going to be analyzed.
So it has to be done here also.
Sir?
The steel on the concrete specifications.
Yes, sir.
You have to specify here also.
Yes.
Just like you did for the other one.
Yes, sir.
So this step has to be also be done here.
Followed. Yes, sir.
So if you must keep it because you know it.
Yes,
you have to do it when you are going to this one.
Exactly. We already know that part.
Yeah.
So it's just the same thing. So it's still loading. It may take a little while to finish.
Now, gentlemen,
Sir?
does it mean that the concrete design
Yes, sir.
and the reinforcement, is it going to be done at the background now, or is only going to concern with the
Still.
now? That's
No.
why it's analyzed
Okay.
now.
The both of them are being analyzed at the same time.
Okay.
That was why I checked the column, and I also checked the steel.
Okay.
I checked the reinforced concrete column,
Yes.
and I also checked the steel.
Okay.
So the both of them are analyzing at the same time. Exactly. So if you go to post, if you come to if I close that, if I come to my design here, if I come to my beam, this one's, sorry, let me bring it here. This one's now tells us our steel beam truss. We can check the ones that failed, the ones that passed, and all that. This is it. This is the list. So you can see everything has passed. But if you check the utilization ratio, this is 0.02, less than 1. That means this cross section is actually very high.
Over design.
So yes, it's high. It's not economical actually. So
what percentage do you think should
sir?
What percentage do you think?
And this is a guide.
Okay.
It should not be greater than 1, but close to 1.
Yes, that's more efficient.
It's more economical when it gets too close. If it is very close to 1, that means it's very economical.
Yeah.
But 0.02 is actually very, the cross section is very high.
So you revise it. It's advisable to revise it.
Yes, sir. And the utilization ratio you see here is 78, less than 200. So it's supposed to, that means it's just using 78% of 200. That means it's not even using up to even 50% of the one. That's basically the entire terrain sheet this thing is telling us. So from here, I can reduce the cross section of that particular steel.
Right.
If I reduce this cross section of this column, you will see this value will increase.
Yes.
So let's try it now and see. So I will change the section. 305. But although Bomusa, what they call it, Bomusa cladding bar, that cladding is like a roof covering that you can apply the roof load on top. We didn't put that, so that's one of the reasons maybe why that thing is looking as if the cross section is too big. But let's assume, Chiwa, truly speaking, is too big. We can reduce this cross section. Remember the value is 0.02. Now if I reduce this now, you realize that that value is going to drop, increase from 0.02 to probably 0.5 something or 0.3 or however. Let's just click on select and click on OK. Now if you check the information here, check for combination forces, this axial utilization ratio is still 0 point. But if you check, the slenderness ratio has increased. It was 70 something before. So that means we still need to go further to change the cross section. So this is where the major work of steel design is. You have to.
It's the same as electrical engineering. When you transfer a cross section of a cable, and it is showing you that it's not economical, you have to go back to the same process you are doing now. You increase or decrease.
What if you change the direction of the bending? You know your H is this way. What if you twist it?
If you rotate it, I don't think it may really have much effect. I don't know, but it will. But the difference may not be very much. But we can try it. So, but for the purpose of this class, you can be able to tell the utilization ratio or interpret the utilization ratio, slenderness ratio, and all of that. So by selecting now you can see the utilization ratio has increased to 0.043. Now the slenderness ratio, Shima value has increased to 117. Yes, so it has increased. So you, as the engineer, your design is not just only to be safe, but it should be economical as well. So you have to make it safe and also economical in order for your clients to be able to conveniently pay for. So we can go further to keep changing until we have a reasonable cross section that is safe and also economical. So, but like I said, it boils down to your experience over time. You'll be able to know from your field experience, you know this is the cross section that is okay. So you don't have to come and keep troubleshooting over and over and over until you are able to get a cross section that serves. So, but from your years of the experience, you can be able to know, okay, I will adopt this particular cross section and it will serve me. So you can see the slenderness ratio has also increased to 1:6:2. But whatever you do, make sure this slenderness ratio does not exceed this 200. It can go very close, but it should not exceed. The moment it exceeds 200, that means that cross section is too slim. So I can go further to drop it. This is the least we can have on this. You can switch to another, maybe Eurocode. Eurocode has a higher list of steel cross sections, more numbers of steel cross sections rather. So, but if we are maintaining this, this is the list we can go, and you click on OK, and you click on OK. So you discover that among them, this is the most economical steel cross section. The other ones, the cross sections are too large. So what you do, you can probably go back and change the entire steel cross section to the most economical that you have troubleshoot. I don't know if it is making sense, or should I repeat the process all over again?
Yes.
Sir?
Yes.
I should repeat it over again. Gabadia model, eh? Where? Okay. Okay, fine. Sometimes you know definitely this column and this column are not really carrying much load as this one and this one. So it's important you use the columns inside, because you know they are more critical than these ones. So if I come to this drop down steel, if I go to my column, column 1, column 2. I think the second one here should be column 2. So all you need to do is just to double click on that steel cross section and click on change section. So once you click on change section, it's going to bring you here. But in order for you to have the liberty of selecting another cross section, you have to click on this again. When you click on it again, it will bring out this for you. So even in your manual design, this is how it's like. You pick from, it comes in this form. So you select a cross section that you feel will be more economical, and you click on select and you click on OK, and then you as well click on OK here, and it changes it. So you can see this one 0.24 the utilization ratio, and the slenderness ratio is 1:6:2, which is less than 200.
Can't you select them all and include at once?
No, you can't. From here you can't, except from the model. From the model here, you will have to change the entire steel. So this one now just helps you. The first model you do is just to guide you on, okay, from there you will know, okay, this is the cross section that is more suitable for this design. Then you can come back, and like I said, it boils down to your years of experience. Somebody who has been into steel construction for steel designs or steel construction on site for many years, he already know in his head that this steel cross section, this is the one that will most likely serve. He will not have to start going into trial and error. What we are just doing now, we are just testing different steel member, because of the young ones that are here, that we the young ones. So is it making sense? Okay, so similarly for this, just like the way we did for steel, it's the same way you do for your brace, the same thing you do for your pull line, the same thing you do for your guards, the same thing you do for your trusses. Now for the trusses, the section that usually fails the most is the bottom cord. So you see this one now, slenderness ratio is way above 200. That means it's very slim, but it still pass when it comes to the utilization ratio. But the slenderness ratio is higher than 200. So what this means is that we need to increase the cross section of that truss, because it's too slim. Yeah, it's really there. That's what it means. So all we need to do is to, the steel has passed, but we just need to change. Good, you can see this bottom cord is where you always have one. So you have to change this cross section of this bottom cord and change it to a smaller cross section. So you can use a smaller one, 90 by 97, and I click select and I click on OK. When you check, you will see the value here is going to change. Utilization ratio, it increased, sorry, I reduced it, I'm supposed to increase it. Sorry, I'm supposed to increase it rather. That bottom cord, that's what I'm saying. That bottom cord always requires a sometimes higher cross section. Yes, so I'm supposed to increase it. So if I increase it now, you see the value will change, will drop to 364. So I can go further to keep increasing that cross section until I have a suitable cross section that fits what I am looking for. I don't know if it is making sense. So if I choose another cross section, and you can see this one is double, you can make it a single one, you can even make it in 4, 1 2 3 4. So but if I leave it in the double and I click on OK, it has gone very high, safe. It has gone very high. It has gone, yeah, because this one is 20 28. So if I can use 50, 150, 150, 10, definitely it will drop. It has dropped. So we are almost there. So that's basically what you need to do to choose a suitable cross section that fits your design. The moment you get that, you click on OK. Once you click on OK, and that is all, then you can probably jot down the particular cross section that is okay. Then you can come back and remodel it. You don't even have to remodel, you can just double click on it. From here you change the cross section. You can change the cross section. So this is a summary of what you can do with the Protasteel, but there are so many things you can achieve. You can even your, what they call it, is it monopole, or what they call it, like the steel mass, all those telecommunication distinct. Yes, you can model it and design it here.
Yes.
your warehouse, your stand, all this, sir.
Still, job.
Steel tower is not.
Take a tank.
Is model. It may take a little longer time for us to achieve that model. Modeling, if you know how to use the tools, to achieve. I think I even have one that I have done before here. If I'm not, I don't want to close this, but I have an existing one that I have done before.
Why is it that the popular jet line is not included here?
This is a says Z Poline.
Among the ones you have selected, to be selected, the Polines members.
Okay, it's not included.
I have not seen that.
No, these are Z Polines.
Okay.
I should zoom it.
You mean one and that can model in
A selection in it.
This is a Poline now.
What is
I'm not talking of Poline.
Z for line? You talk about Z for line.
In the area where you have to select in the table,
The shop.
there's no representation of Z Poline at all, and it's popularly being used in practice.
Sorry, Bangani question in Kabasa.
What
What table?
What you have lines? What the templates now?
Directly selecting them.
Under the
Polines.
Poline, have it?
Yes, yes.
Yeah, under Poline. When you open it.
Sorry, let me go to model D. From here, come to Poline. Then I'll have to delete this one I say first.
Okay, to not show that again.
Na gane wata yana.
Click.
Cikin chat ɗin wa
Babu shi.
babu zai kona shi.
Maka ban line.
Ba za a rasa ba.
Akwai shi. This is actually the Poline geometry. This geometry now, you can select here. It brings you here. Yeah, the different templates. There are so many. No, it doesn't come.
What number sections in it?
Section. Section. From the section. From the section. This is the suitable. This is the most suitable one that you can use here. Okay, more questions, sir. Abi is too confusing, Abi. Okay.
Very straightforward.
So if once you are done with the analysis, because we have tampered with it now, the analysis is no longer going to be up to date. We have to reanalyze it. Where the major work is on the Protasteel. That's where we do the major work, where we begin to insert our connections, create a base plate, and all. That's where the major work is. But there is no steel that you cannot model here. You can even import. There's no steel you cannot. Even elevated tanks. However, the cross section of the steel comes, you can model. So importing it shima ba another wala, but we've demonstrated the concrete one how to import. Just wait for it to finish loading. So once it's finished loading now, the design, we can switch to the Protasteel. Click on OK and we close. So we are assuming everything is okay. The cross section, none of them is too large, none of them is too small, assuming, because taking your time to change all of is really time taking. To take you time to get a perfect cross section that suits. So all you need to do, assuming everything is okay, is to come to Protasteel. Once you click on Protasteel, it's actually going to take this model now to your Protasteel. You can see it's loading. This Protasteel, I think this is the steel aspect, I think is owned by another company. This company is Comosis. So sometimes mutane suna samun damuwa da shi Protasteel din, because license din yana iya expire kafin shi normal Protast structure din. So even when you are using a crack Protast structure, za ka gani steel na kaya da yana yi.
Sai ka sake cracking.
Ba ma abin da za ka yi ma, sai kawai an samu fix. Say an samu fix. Sometimes there's what we call fix that you can use in fixing that steel. So it's here. This is the model now in Protasteel. So if you look at by the right hand corner of my screen, this is right hand side of my screen rather. The interface is different from different versions. For the 2021, the interface is not like this. And the 2018, the interface is also not like this. This is the interface for 2021. If you look at this here, you have different types of connection. Got beam to beam connection, got beam to column connection, brazing connection, splice connection, pull line and guards connection, base plates, under Tamba. We have the base plate here. Truss connections is here. Detailing here. Sometimes you can do some little detailing here. Auxiliary steel work here. You can have all those handrails, and then you can add a handrail in a case where you have what do we call this, mezzanine floor. In the case where you have a mezzanine floor, you may have a handrail, this and a rail, and the gas now. So what else? Miscellaneous anchor bolts. We are definitely going to use anchor bolts. I'm going to show you how to do that. User defined. Shiwan Nankuma is you defining it as a user and all that. So okay. So here now, the first thing I'm going to do, it has a very powerful tool called the IntelliConnect. But that IntelliConnect is supposed to help you check the entire model and provide connection where it is needed. But that IntelliConnect is not, it's artificial intelligence, but human being never mireba. So she sometimes at some point. So there are some connections that it may not provide for you. So you must manually insert those connections by yourself. So what I would need to do now is to highlight this particular model. if I highlight it, I will right click and I will come to IntelliConnect. You can see create pull line connection, create GATT connection, create SAG connection. As I'm clicking, it's creating them for me. So if I want to create a pull line connection now, I will just click on create pull line connection. Now it's very smart. You can see, I will advise you leave it on auto, except if you really know what you are doing. If you leave it on auto, automatically it's going to choose the best type of connection for that pull line for you. So I will click on next, I will click on run. Now the connection has been done. So if I zoom closely, you are going to see the connection for my pull line. You are seeing the connections. Similarly, I will highlight. Now it has created for my GATT too as well. Tunda, that option is for GATT and pull line. I think so. Let me highlight again and check. Right click, come to IntelliConnect. Okay, it's different. The GATT connection, click on create GATT connection and leave it on auto and click on run. But if you know what you are doing very well, you can pick the particular one you want it to make use of for you. So if you zoom closely, you will see that connection. We won't be able to see it here except I rotate it. To rotate perfectly, hold on shift and hover your mouse. Hold on right click the mouse and hold on shift. You can see those connections for our GATT has been created. So from the Protasteel structure, you can't see these connections. They are not there. You can see they are not there. They are not there. So but on the Protasteel, the connections have been created. You can see these are bolts.
Yes.
I can also highlight and I will right click and I will come to IntelliConnect again. We have a SAG rod in the GATT, so I will click on create SAG rod. That has also been created. Good. You see, some are telling you could not be connected, but that's basically what I was saying. So some of them you will have to create them manually. So you have to go through the model and check some of those areas they be creating, but say creating the kanka. So while it's still highlighted, I can also highlight, right click rather, button plate, splice connection. One base plates, corner clicking ma they creating ba. So we have to do it manually. We'll do it manually, but let me show you. Create base plates. Let's say I pick this one with the stiffener. Let's say I pick this and I click on run. You see what? It didn't connect it. So what can do by that? I can buy base plate them. So I will right click and I will come here. We have trusses. We have bracing too. So let me create a bracing connection. It will ask you for gusset plate, sir. Kashina. So you specify the thickness of your gusset plate. So let's say I want to use 8 mm thickness of my gusset. If I click on run, it's going to create a gusset plate. You can see the gusset plate has been created. Now let's zoom and see. If you check, you can't see it like this here. Let me rotate this one. Look at it. So I will highlight as well, and I will right click and I will come to my IntelliConnect and sorry, where are we now? Gusset plate bracing bar. I will click on create truss connections and shimaze tembeni thickness na plate dina. So let's say I want to use 8 mm thickness of my plate and I will click. So you can see some of the truss connections were not created. So some of them she must say manually, just like I said. Okay, this is a different model.
It's different. I noticed this is more or less portal frame.
Wancan portal frame ne. Siyasa trust din bai ba. Okay, this is a different model. Oh, abun ya loading different one ne. This is portal frame. Sorry. Ina gan ya. Okay. Sorry. Sorry, a different model ne ya bude. 2022 ne wannan sa. But the process is the same. But the process is the same. If time permits us, ma zan bude wancan. Okay. But the process is ba wani babbanci da ne. Kawai the difference shine wannan portal ne, wancan kuma trust ne. Different model. Dan wancan abun kamar ya zo ya nuna mana wani error azin. Daban ne. Amma ba damuwa bane. We can still load that other one, but as this one is open now, the process din da ne. Kawai process din da ne. Ba babbanci. The process is the same. Kawai you highlight it.
So when it comes to the connection.
Say the connection. Shima abun ma is intelligent. It does it automatically for you. Okay. With stomach infrastructure.
So yanzu nawa ne ka ɗauku ne ba? It's only 3 o'clock. Why don't you go 3:45? I mean 3:25. Sai ku ci abinci kafin 3:30. Sai mi sallah.
Yanzu abin da za a yi yanzu nawa ne?
Sallah
3 o'clock ba.
3:30 ba?
3 o'clock yanzu dai.
Abin da zai debate is suna so su ci abinci ne yanzu?
Suna so ci.
To kan wannan ku ci abinci shi mai sallah dawo.
A ci abinci kafin sallah.
Shi ne a ci abinci.
A yi great ne.
Ku je ku ci abinci.